Okay, yeah, this was the more density math practice. Real quick, I apologize for my voice. I don't have much one right now. I just want to define density. That density is the amount of stuff. So it's the number of grams in 1 unit of space. Okay? So when it asks for a density, we already know this unit. We're not sure of this one. So the block of aluminum occupies a volume of 15 milliliters and weighs 40.5 grams. So we can change that up a little bit. We can make that a for every statement. So we can say for every 40.5 grams of aluminum, there is 15 milliliters of space. And then it asks for the density. So we just want to know for every blank grams of aluminum, there is 1 milliliter of space. Okay, so to get here to here, divide by 15. Get from here to here then, we'd also divide by 15. And if we think about this, 45 divided by 15 would be 3. And so it's a little bit less than 3. And I would pull out a calculator then and figure that out. And it would be 2.7. And if we look at the number 6 figs, this needs to be 2.70. Okay. What volume of silver metal will weigh exactly 2,500 grams? And they tell us that the density of silver is 10.5 grams per centimeter cubed. So that density tells us for every 10.5 grams of silver, there is 1 centimeter cubed of space. Right? That's what that density tells us right here. And we don't want to know 10.5 grams. We want to know 2,500 grams of silver. There is blank centimeters cubed of space. Okay, so to get from here to here, well, it's getting a lot bigger. So we can take 2,500, divide that by 10.5, and that comes out to be 238. So it's 238 times greater. 238 here. And that is the proper number of significant figures. Okay. All right. If you can do 1 and 2, I'm pretty confident that that's pretty much all we're going to ask you to do on a quiz. These are more challenging problems that might, come up as like one question on a quiz or a quick one, just to test to see if you can do something like this. In the United States, copper pennies, made since 1983, actually contain very little copper. If a penny contains 93, let me just underline that, 0.975% of its total volume zinc, and then the other percent is actually copper, what is the apparent density? So they want to know, here are the two densities of those two metals. Now we got a little bit of work we got to do in order to figure out all the rest. All right? So we could say for every 8.94 grams of copper, there is 1 centimeter cubed. And then for every 7.14 grams of zinc, there is 1 centimeter cubed. Okay, so this tells us that basically this is the percentage. So this is 0.93975 centimeters cubed of space is zinc. And down here, 0.06025 centimeters cubed of space is copper, back up here. So if I multiply those two out, this will be times 0.93975 times 0.93975. That is 6.7 136 grams of zinc, and then the rest of it's going to be copper, so this will be times 0.06025 times 0.06025, and that is 0.539 grams. And if you think about it this way, like when we add these two values up, they are 1 centimeter cubed. So if I wanted to know how much those two as 1 centimeter cubed weighed, I just add these two up. So that's 6.71 plus 0.539 is equal to 7.25 is the correct answer. Write that up here. 7.25 grams per centimeter cubed. Again, the reason that works is because these two numbers add up to that 1, right? And then these two numbers must add up to the amount that the mass is. Okay. Number 4. Object A is less dense than object B. If both objects have the same mass, what can be said about the volume of object A compared to the volume of B? All right, so if they have the same mass, that means they take up the same amount of space. So if we, or the same amount of, there's the same number of particles. So let's make object A be one circle is equal to 1 gram of A, right? And then let's make object B, we got an A. Object B, one triangle is equal to 1 gram of B. So let's just say, for instance, we've got 3 circles of A, and that means we've got 3 triangles because they said they have the same mass. But it said that object A is less dense. That must mean that there's more spacing, when the only way that there's more spacing is if the container is bigger. So object A has a larger volume than object B. Now there's mathematical ways to figure that out too, but drawing a picture certainly can help you think about that, I think. All right, and then 5 and 6 are really tough. They require a little bit more, but you guys can do this. We know that for every 22.57 grams of osmium, there is 1 centimeter cubed. And then it says there's 1 kilogram, which is 1,000 grams. A block of osmium has 2 dimensions. Calculate the third dimension. Well, for every 1,000 grams of osmium, there is some number of centimeters cubed, right? So I can figure out the volume that 1,000 gram block takes up. So 1,000 divided by 22.57 means that in order to get here, I'd have to multiply by 44.31. I'm not going to worry about rounding my answer right now because I don't need to. Here's the thing. This is a block, right? And we've dealt with these things before. It has 3 dimensions. And to figure out its volume, you have to do length times width times height. Well, I have 2 of the dimensions right here. And I just solved for the volume. So now I know that 44.31 0.31 centimeters cubed is equal to 4 centimeters times 4 centimeters times the height. So 45 divided by 16, that's going to be 2 something. 44.31 divided by 16 is, the height is 2.77. This is where I need to round, like 3 sig figs, 3 sig figs, so centimeters. Okay, and the last one is pretty tough here. So it tells us that we've got some salad dressing, and it's composed of olive oil, and vinegar. And then it tells us that the salad dressing has this many grams and this many milliliters. And you should get like wide-eyed and be like, oh yeah, I like that. I'm going to write that out, right? Because you get all excited because you're like, yeah, I know what to do with that. I'm going to write that out as a forever statement, right? So for every 402.3 grams, there's a total volume of 421 milliliters, and you say, you know what? I am going to turn that into a density. I don't know why I'm going to do that, but it seems like a pretty good idea. And that's the key, guys, is that if you just try stuff, sometimes it jogs your ability to try new things here. So you got this divided by 421. Now, some of you are saying, Mr. Stick, I don't even like salad dressing. I don't care about this. Well, it's kind of a cool little logic puzzle, though. So, all right. So we see, all right, this is 0.9556. All right, so here's the density of the salad dressing. All right, now why did I do that? Well, I've got the density of the olive oil and I got the density of the vinegar. This number better be in between those two numbers. And it is, which is good. So we've got olive oil over here, which is 0.918. And on the other end, let's pretend like we got a little number line here. On the other end of this number line, we've got vinegar, also known as acetic acid, is 1.006, right? So this is my vinegar. Okay? In between this is the actual density, 0.9556. Now, one of the things you might want to do is just say, oh, you know what? That looks like it's kind of in between those two numbers. Is it? I mean, because if it is, we're kind of done with this problem. We've got a 50-50 shot. We've got a 50-50 mix. So if I take the 0.918 and the 1.006 and I add them together and divide by 2, I fall at 0.962, right? So I'm pretty close to being 50-50, just not quite. It's real close, though. This 0.9556 is less. So that means that we've got a little bit more than 50%. Just a little bit more. It's right about 50% vinegar. It's a little bit greater, right? And that means that this number is a little bit less than 50%. Okay, it's pretty close to 50% too. And I gotta tell you, if you figured that much out, I think Mr. Voigt and I would be pretty happy that you figured all that out. So let's talk about, though, if you wanted to know the exact answer, you got a couple choices. You could solve it by trial and error, or you could, now that we know this much, we could actually set up a system of equations, which I know some of you are so excited about. For a math class, a system of equations. You're like, yeah, that's what I want, system of equations. All right, so we know that there's some percentage of olive oil. So we know that, we're going to let X equal the percent of olive oil. And then we'll let Y equal the percent vinegar. Now, again, if you're checking out here or you're not sure, don't worry. There's not going to be like anything like this on this quiz, okay? But kind of wanted to give you a little bit of a challenge problem. So we know that x plus y has to equal 100, right? Those two percentages better equal 100, okay? And then we also know that if I take 0.918 times the percentage plus times x, plus 0.9556 times y, right, the percentage, I should get, I'm sorry, this should be 1.006 times the percentage. I should get 0.9556, right? Now that will only work though, and here's the problem. We got one little problem right now, which is that only works if that percentage is a fraction. So I can do a couple of things here. I can either change this number here, or I can change this number here. To me, I would just change this number here from 100 to 1. Because when I'm multiplying, I'm not multiplying by the percentage. I'm multiplying by 100. Like if I want 10%, I wouldn't multiply by 10. I'd multiply by 10 over 100. So I would say this is x plus y is equal to 1. Okay? Okay, so x plus y is equal to 1. So we're going to say that y is equal to 1 minus x. Y? I don't know. Y is 1. Oh, no, I'm just kidding. All right, so y is equal to 1 minus x. And that way I can plug that in. And now I can use this system of two equations to solve for two variables. So I've got 0.918 times x stays the same, plus 1.006 times 1 minus x is equal to 0.9556. Okay. If we take those factors out, I'm running out of space. All right, so now I'm going to factor this out. I made some room up here. I have 0.918x. That didn't change at all. Plus 1.006 minus 1.006 x is equal to 0.9556. Okay, and then I can just go ahead and do like factors. So 0.918 x plus, minus 1.006 is negative 0.088. X is equal to 0.9556 minus 1.006 is negative 0.0504. If I divide both sides by negative 0.008, I lose that side, negative 0.088. And I get x equals positive 0.57, which means that my olive oil is 57%. And that means my vinegar is 43%. Okay, I hope that helps. I hope I feel better. See you guys.